So if xn, what about time delay operation? Okay, I'm writing it here. This is the time shifting property. If you shift in, if there is a time shift, then multiplication with z raised to n naught. Now, can you tell me what will happen to the ROC? Remember when we derived the properties of Laplace transform, we look for the location of poles, whether some pole is getting cancelled or if some new pole is introduced, then the location of the ROC shape of the ROC changes, isn't it? If the location of the poles remain the same, then there is no change in the ROC. Now tell me, in this case, will there be any change in the ROC? Does it introduce any new pole?
Yes, sir.
Yes. Where?
Z equals 0.
Z equals 0. So only possibility is that z equal to 0. This may be, and it is not guaranteed. For example, if you consider xn minus 2, that means this is xz into z raised to what? Minus 2. If xz is, let's say, if this is of this form, then what will happen? Will it introduce any pole? There will be no pole. So we cannot say that it will introduce a pole, but there is a possibility that it will introduce a pole. Now, okay, the example we have already discussed. And then delta n plus 1, delta n minus 1. These three cases we have already discussed. So this is xn n plus 1 and this is xn minus 1. Okay. So will it change the ROC? This one is the entire z plane. If you are shifting it left by 1, it is delta n plus 1. Will it change the ROC? That shift?
Yes, sir.
It will change. Okay. So the property is that there may be a change in the ROC. Only change will be at this point. This point may not be in the ROC. If earlier it was in the ROC, there is a possibility that it will get cancelled because of the newly introduced pole. Okay. So that is the only change. Okay. If x of n, this is straightforward, proof is straightforward, is x of z, that is, so what about z to the power n, z naught to the power n, x of n? What is the z transform? Is it this? Can we write it in terms of x of z? This is what? Is it? Tell me what is the relation with this? Is it this? Replace z with z by z naught. So that is the property. If xn, the z transform is x of z, if you multiply with can you tell me about the ROC? Will it change the shape? Suppose R is the ROC. Will it change the ROC? Location of the pole will change? change or not? Let us
It will
consider,
change.
let's say if x of z is of this form, and if you are multiplying with this one, what will be the expression for the z transform of this? Will it be, is it this? Here there is a pole at A. Where is the pole here?
AZ node.
So there will be change in the ROC, isn't it? And that depends on expansion or compression. That depends on the value of Z naught. Okay. So the ROC will change. Okay. Next property is the time reflection property. What about x of minus n? What? That is summation minus infinity to infinity x of minus n. Isn't it? That is a Z transform. And we can, if you replace n with minus n, you will get is it this? Now tell me what is the relation between this? The transform of x minus n and that of xn.
X is raised to minus 1.
Okay. And in the case of Laplace transform, it was x. Sorry, it is. Sorry, x of not x of z equals to x of minus 1. The z transform of this is x of z to the power minus 1. Okay. In the case of Laplace transform, x of minus t, it is x of minus s. But here it is z to the power minus 1. And what about the ROC? Will it change the ROC? Will it change the ROC?
Poles and zeros will exchange.
Poles and zeros will exchange or something different? Let's say x of z is simple case. There is a pole at 0 at 1 and pole at 3, isn't it? Now if you consider x of, then this expression will be, is it? What is the location of the 0 now? Is it this? In this case, it is the same. What about pole?
1/3.
1/3. It is not exchange. Okay. So if there is a pole at, let's say, z equals some value z naught, then where is the location of the new pole? It is at this
1/z node.
1/z naught. Okay. That is the change. Now, if a signal is even, what does it mean? Xn is equal to x of minus n. That means x of z is. Then can we say something about the location of the poles and zeros? So poles of xz must be same as poles of xz minus 1, isn't it? If it is an even signal, these two are equal. Suppose there is a pole here. Can we say that there will be always another pole at some location? What is that location? First, let us consider in the real axis. Suppose there is a pole at A. Then there must be another, if the signal is even, there must be another pole at
1
where?
by A.
At 1 by A. Isn't it? 1 by A. And here I am assuming that a is greater than 1, otherwise this 1 by a will be here. Okay. So if there is a pole at a, there must be another pole at 1 by a. And what will happen? Okay, time reflection. What will happen to the ROC? Will it change the ROC? Will it change the ROC?
Yes, sir.
Yes, it will change the ROC. You can easily find that. For example, if there is a pole at, suppose the initial signal xn is right-sided, and there is a pole at this one. What is the shape of the ROC? If xn is right-sided, there is only one pole at A. What will be the shape of the ROC? It is outside this circle, isn't it? If we assume that it is a right-sided signal. Now, if we flip the signal, then x minus n, where is the pole? This pole is at A, new pole is at 1 by A. What will be the ROC? Right-sided signal, you are flipping a right-sided signal. Is it this? Inside. So the shape of the ROC changes. Okay. So we can say that if it is an even signal, and if we know that there is a pole at A, then there must be another pole at 1 by A. Then only the signal is even. Okay. Okay, next property is the conjugation property. I am writing this. Conjugate of this is the property.
Excuse me, sir.
Yes.
Sir, in the last property, if it is an even signal,
Mhm.
then what would be the ROC if it is finite duration?
No, ROC will not change in that case. Even signal. Even signal means location of the poles will, even after flipping that, the location of the poles will remain the same, isn't it? Is it?
Yes, sir, the location of the poles would remain.
Uh-huh.
I was asking what would be the ROC of the original even signal.
No, even signal means what are the possible signals?
That would be finite duration or infinite.
Finite duration. If it is a finite duration signal, then there is no pole. Okay.
Oh,
If there is
okay,
a
sir.
finite duration signal, there is no pole. Otherwise, there will be pole. And suppose, okay, let us consider that case. Suppose there is a pole at A, there must be another pole at 1 by A. What will be the ROC in this case?
Sir,
But-
it can be.
But it can be.
It can be outside the outermost one, or
But outermost pole, it is what even signal means. It must be. It is a two-sided signal, isn't it? Is it a
oh, okay,
two-sided?
sir. It would be between 1 by A.
The ROC in that case will be this region. Is it? ROC is in this region. It is a ring. And depends on the even signal. Not all the even signals have this Laplace Z transform. If it converges, then it must be this ring. Okay. Does it answer your question?
Yes, sir. Understood.
Okay, so this is the conjugation property, and this also proof is straightforward. Please refer to the textbook, and this is given in the formula sheet also. Can you tell me what will happen to the location of the poles? If there is a pole at some location, let's say this one, then sorry, it is yeah, if there is let us consider this something like this, x of z is this. Now if we take the conjugate, this is, tell me what is the pole of this. Here there is a pole at A. Now where is the pole of this? If xz is this, then what is x star z star? Is it 1 by Is it this?
Yes, sir.
Where is the pole? Pole is at
A conjugate.
A conjugate. Okay. Earlier the pole was at A, now it is at its conjugate location. So you can see the ROC. Will it change the ROC? Will it change the ROC?
No, sir.
No. Why not?
Because the magnitude of Z remains the same.
Because the magnitude will remain same. If A, because remember the ROC depends only on the magnitude of Z. Okay, and A conjugate are having same magnitude because they're having the same magnitude, so the shape of the ROC won't change. Suppose there is a pole here, and if you take the conjugate, this is here, and both of them lie in a circle of radius, that radius mod A, isn't it? So the shape of the ROC won't change in this case. Okay. If the signal is real valued, what? What does it mean? Location of the poles and zeros?
Poles must occur in pairs of conjugates.
Yeah. So we can say that if there is a pole at some value Z naught, then there must be another pole at its conjugate location. If there is a pole at Z naught, if the signal is real, there must be another pole here. Because the poles of these two should be the same. So it should occur in pairs. Okay. Now tell me what about real and even signal? How many poles? If you know the location of one pole, then what about the remaining poles? At least how many more poles will be there? The signal is real and even.
3.
There are at least three more poles. Which are the location? If the signal is even and there is a pole at Z naught, there is another pole at 1 by Z naught. And if the signal is real, then there is a pole at and isn't it? So there will be 4 poles, Z naught, 1 by Z naught, and again it depends on the location. It is not necessary that 4 should be there. For example, if you are considering a pole, let's say here in the real axis, how many more poles will be there?
1.
1, or if it is real and even, there will be another pole here, isn't it? 2 poles. Yeah, 1 more pole. Because if it is real valued, then these two are the same. Okay, so it depends on the location. Okay, so that is the conjugation property, and we'll discuss one more property, that is the convolution property. Convolution property is also straightforward. Then what about x1n in convolution? It is convolution in the time domain, multiplication in the z domain. Okay, this is the convolution property, and the shape of the ROC, I am leaving it as an exercise. You can find what will happen to the ROC. If this is R1 and this is R2, tell me what is the ROC of this? What is the relation between these three? If this is R1 and R2, Is it something like this? R is a is it this? You can verify this. Yes, please see the previous video. I have explained it for the Laplace transform.